Okay, so hello everyone. So in this video, what I want to do is I want to go over a problem where we kind of try to evaluate certain input values for f given a function that is graphed from a graph, right? Basically, so this is kind of the problem here. The first question, and it kind of asks us, determine whether the graph of f of x is a one-to-one function. And then we're basically going to evaluate each expression, right? So, so basically, what a one-to-one function is, it means that when we have, for example, a curve, so if I just kind of go over the definition very quickly, this basically means that, so let's say we have some kind of curve here, and we want to know if this graph actually follows the horizontal line test, and where every input, or every output, excuse me, only has one input. So basically what I'm trying to say here is every y value, so like for the y value there's only one x value, and that has to be true if for a function to be one-to-one. So basically, let me kind of repeat that. A function has to be one-to-one if and only if, so let me just type this down. A function is one-to-one if and only if basically every output, which is your y term, only has one input, which is your x term, right? So this is kind of what I'm trying to not enforce, I don't want to say that word, but basically I'm trying to make y'all understand that this is the definition that that we are basically, that I'm trying to enforce here, I guess. So basically, hold on guys, one second. So basically what I'm trying to say here is that every output only has one input. In this example right here that we have, this is not really true. So like basically, if I do the horizontal line test, and this is connected to the horizontal line test, by the way, basically if there's one part here and there's another part over here, so this output of y has this input as well as this input up here. So we obviously know this is not one-to-one, right? So looking at this graph, we kind of see, if I do the horizontal line test all over, right? I'm going to be doing this, and you basically see that there's multiple like parts in where the graph intersects twice. So for example, so for every output, in order for it to be one-to-one, again, every output only has one input. This is the definition. So what I'm trying to say here is, to solve this problem, every y value actually has two x values. So if that happens, this is not one-to-one because it crosses the horizontal line test twice. So horizontal line test crosses twice, right? So that is how we know it is not one-to-one. Now, for number 2 and 3, so it is asking us what is f of 2. So in other words, what is y when x equals 2? So when x equals 2, if I draw, for example, a little dotted line here, and I go up here to 2, what is my y value going to be, right? And I see here that we intersect the graph right here at this point, and that intersects at y equals 4. So f of 2 is actually going to be 4, right? Because when x equals 2, y equals 4, right over here, okay? Now, when f of x equals 4, what is x, right? So, actually, well, no, I'll keep it like that. So when f of x equals, when f of x equals 4, what is x, right? So when they give you something like this, basically they want to know what this is. So it's kind of like the other problem, but it's backwards. Basically, when we have, here's f of x equals 4. This is f of x is equal to 4, or y equals 4, right? So when we have that, we need to know at what part does it cross this orange line or this brown line here, right? So it crosses it right here, and that means what is x when y is equal to 4? Well, in other words, I can write that down. What is x when y equals 4? So when y equals 4, we can clearly see that x is actually going to be 2. So x equals 2 when y equals 4. So you can say this many ways, right? You can say x equals 2. You can say f of 2 is equal to 4, so x equals 2. So, or you can say when y equals 4, x equals 2, etc., right? They just want to know what x is for this, okay? So that is kind of a brief presentation of a few problems that involve one-to-one functions, as well as just evaluating a function from a graph, right? And so that is it for this video, guys. And if anybody does have any questions, please let me know. And also, please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.